Welcome to Clean Testing. I'm Jason Taylor, an SSW Solution Architect. You can find me on Twitter at JasonTaylorDev. Recently, I've been teaching folks about clean architecture, and I've highlighted the simplest approach to enterprise application development with .NET Core. Tonight, in this talk, I want to demonstrate a simple and yet powerful approach to automated testing with .NET Core. I want to demonstrate an approach where tests are easy to create, maintain, and understand, and give you the confidence to deploy to production, knowing that it will behave as expected. Let's get started. So we'll kick it off with an introduction to clean architecture, and following that, I'm going to provide an overview of clean testing. Next, we'll take a quick look at testing frameworks and tools, and then we'll jump right into the live demos. And this is where we're going to spend most of our time. It's going to be a lot of fun. I had a lot of fun putting this talk together. I think you're going to really enjoy it. Finally, I'm going to wrap it up with a quick summary and some resources in case you're keen to learn more. So with clean architecture, the domain and the application layer are at the center of the design. This is known as the core of the system. Now, the domain layer contains enterprise logic and types, whereas the application layer contains business logic and types. The difference being that enterprise logic could be shared across multiple systems, whereas the business logic is the logic that's specific to this system. If you've heard my talks before on clean architecture, you know that I often use Northwind Traders as an example. So an example of business logic in Northwind Traders would be create an order, or create a customer, or update a customer, those sorts of things. So now core should not be dependent on data access concerns and other infrastructure, so those dependencies are inverted. So infrastructure and presentation depend on core. Now this is achieved by adding interfaces or abstractions within core that are implemented outside of core. A good example is messaging. If we wanted to have some sort of messaging capability within core, then we could say add an interface, messaging service. And outside of core, inside of infrastructure, we could add an implementation. Now, it doesn't actually matter what that implementation is at that point. All of our business logic that we include inside core can just run against the interface. We can change that implementation, say from Twilio to SendGrid to a local SMTP server, anything we want. And as long as that messaging interface doesn't change, our business logic is not impacted by that. So you can see that all dependencies flow inwards, and core has no dependencies on any other layers. Now, infrastructure and presentation both depend on core, but not on one another. And that's very important. If, as an example, we had presentation depending on core because it wanted to access that messaging service, well, then that would be a dependency on a concrete implementation, which would be not great because we couldn't change that implementation. We'd be fixed in using that in presentation. But also, it would mean that we'd have to put logic in presentation to orchestrate that interaction. The interaction between, say, for example, an ASP.NET controller and the messaging service that we're using. So we want those dependencies to always point inwards so that we can keep the logic within core. So this results in an architecture and design that is independent of frameworks. It doesn't require the existence of some framework. It's testable, and that's why we're here tonight. I'm going to show you a very simple and powerful approach to testing systems that implement these principles of clean architecture. It's independent of the UI. So right now we might be using an Angular application, soon we'll change it to Vue, and next year we'll change it to Blazor for sure. It's independent of the database. Right now it's using SQL Server. We've tested it with Postgres. We might use to Cosmos DB in the future. It's independent of anything external. So in fact, core just doesn't know anything at all about the outside world. And that's what makes this design so great. It's the difference between something that's going to last 3 years and something that will be still around in 20 years. Now that's quite a brief introduction, but I do have this video that if you'd like to learn more, you can check this out. This is my Clean Architecture with ASP.NET Core 3.0 talk that was recorded in NDC Sydney last year. So certainly worth a look if you're new to the topic of clean architecture. So now we get to have a look at clean testing. That's why we're here. So first I want to look at the typical approach to testing. With the typical approach to automated testing, the focus is on unit tests, integration tests, and UI tests. No surprises there. So we know that UI tests are the most expensive to create, and they're also the slowest to run. So we therefore try to minimize the amount of UI tests we create. In the middle, we've got integration tests, and then at the bottom, we've got unit tests. And we know that unit tests are cheap to create and fast to run. So this is where we're going to focus the majority of our efforts. So generally, we're going to try to write a unit test first. If we can't write a unit test, then we'll move up the pyramid and write an integration test. And finally, if this particular piece of behavior cannot be integration tested, then we'll write a UI test. So for some examples, if logic exists in an Angular front end, then we need to write a UI test. We could, of course, use a variety of different JavaScript testing frameworks to do that, but for me, I consider that to be a UI test. Next, if logic exists in the ASP.NET Core controller, for example, then we need to write some sort of ASP.NET Core integration test. Fortunately, ASP.NET Core has really good tools for that, so it's not so bad. But the thing with the clean architecture approach that we're taking is we're keeping the logic completely out of presentation. So that includes Angular or Vue or React, and that includes our web API. Our web API is very simple, just infrastructure. And so we're not going to be looking at writing tests in those areas. So what we will be doing is focusing on subcutaneous tests. So with clean testing, we'll introduce subcutaneous tests into the mix. And we'll still write unit, integration, and UI tests, but the main focus is going to be on the subcutaneous testing. And that's because these tests are the ones that are easy to write and run. These tests effectively verify behavior and integration, they document the system, and they reduce the need to create and maintain a large number of mocks. And if you've built a lot of hand-rolled mocks or even used a great mocking tool like MockU, then you know that can be a real pain. It can be time-consuming and they can be a little bit fragile. So in short, these subcutaneous tests are going to provide us with a great deal of confidence. So now I know you're asking, what are subcutaneous tests? So subcutaneous tests are tests that operate just below the UI layer. Now we talked about this a little bit, but I just want to touch on it again because this can be confusing. So for a single page application, if it was Vue with an ASP.NET Core Web API backend, then just below the UI layer could be below the Vue layer. And that would be appropriate if we have logic inside of ASP.NET Core controllers or endpoints or somewhere along those lines. We could write subcutaneous tests to operate at that point. But again, with this clean architecture that I provide, we're not putting any logic in that layer. So we get to operate one layer below. So we'll look at what that layer will be shortly. So with subcutaneous tests, we're going to verify the basic inputs and outputs of the system. And this provides good test coverage and helps to ensure that tests are not brittle. These tests are only appropriate if you keep your logic out of the UI. I think I've probably harped on that enough. So. And this will therefore reduce the need for UI tests, which is a good thing because we know, as we mentioned earlier, they're expensive to create and they're brittle. They're also slow. So let's have a look at this from a slightly different perspective. So presentation in this layered diagram contains the UI. For a typical SPA, that might be the Vue front end combined with a web API backend, or for a microservice, it might just be a web API backend, depending on your approach, of course. We have core, which includes the application and domain layers, and that contains all logic. It includes commands, queries, validators, cross-cutting concerns, anything else you can think of that you've got inside of core. Infrastructure represents both our internal and external infrastructure. So an example of internal infrastructure might be the database that we're programming against. And keep in mind, these tests will run against a live database. An example of external infrastructure might be the external client API. So the subcutaneous tests are going to operate just below the presentation layer, operating all the way through core and the internal infrastructure, so the live database. And so we're going to actually wire up services for these tests. We're going to wire up a production system to be as close to production as possible. So to ensure that we're definitely on the same page, what we're going to be testing is our commands and queries. So in the clean architecture approach that I demonstrate, the logic is moved out of the front end, out of presentation, and into commands and queries inside of core in the application layer. And those are the entry points for our application. So we'll include internal services. So we're going to wire up things like our live database. We're going to wire up ASP.NET Identity and any other services that we're using in production. But we'll mock our external services. So if there's something such as an external client API that we're talking to, we didn't create that, we don't maintain it, and it's kind of, it can be a little bit fragile to run that as part of our automated tests because we don't know if it's going to be up is going to be down or how it's going to behave. So we will mock those external services. And we really want to minimize the amount of mocks that we write, just keep it down to hopefully just a small few, because that's going to make our tests give us all the more confidence. So we want to keep it simple. Of course, we want these tests to be easy to write and maintain, because that's the approach that we're trying to build here. So with that definition out of the way, let's have a look at testing tools. I want to kick it off with the frameworks that I considered when I was trying to put together the approach to clean testing. So first and foremost, I looked at NUnit. It's a popular choice for many .NET and .NET Core developers, and it's probably the most widely used. Next, we have XUnit. Now, this is by far the most popular choice for .NET Core, and it's also used by a number of teams at Microsoft. In fact, it's probably one of my favorites. Then we have MS Test. Now, if you've seen my presentations before, you know that I love building logos for MS Test. They don't have a logo. This is my latest version. I've used Microsoft emojis this time, so I think it's much more professional than my last version. I hope you enjoy it. So I think MS Test can be somewhat of a default choice for many new developers, and I think that a lot of the time they'll move on to NUnit and XUnit. One other framework that I looked at was Fixie, and this is a powerful conventions-based framework. And the reason that I looked at this particular framework is because it was recommended by Jimmy Bogard in an article, Integration Tests with XUnit. And he basically described that you have to jump through a few hoops if you want to write integration tests in XUnit. You can do it, but it's not simple. And he suggested that something like Fixie or other behavior-driven design frameworks can be much, much better. So I wanted to check that out for myself. And I really did like Fixie. In fact, I built a Fixie.NET Core project template. So if you want to write some tests in Fixie, you can check out the .NET Core project template. So I didn't have time to try out all of these because for 3 of them, I wrote a lot of subcutaneous tests so that I could choose the right framework, but I didn't use MS Test. Maybe I should have. They've put a lot of work into MS Test. I know it's been cross-platform for a while now. It's out of the box with .NET Core. It's fast. So then maybe that's an exercise for next time. But for this particular exercise, I looked at NUnit, XUnit, and Fixie. And I guess, the thing was I had to decide which framework was best for me. So which framework did I go with? Before this, I had been programming with XUnit. And while it's possible to create great subcutaneous tests in any one of these frameworks, I decided to run with NUnit. And the reason for this was for this style of testing, I found NUnit to provide the best support. It was simple. It actually seemed to run a little bit faster for my tests. I didn't actually benchmark that, so I can't say that with authority, but that was the feeling I was getting. They were running faster, and it had great mechanisms for managing global shared state. And when we're writing subcutaneous tests and we're trying to wire up these production scenarios, obviously that's really important. So NUnit 1. So next, some tools. Let's have a look at, first and foremost, FluentAssertions. This tool contains a large set of extension methods that allow you to more naturally specify the outcome of your test. And it also improves the readability within your tests. So that makes your tests easier to understand. And that's one of the goals of this approach. Tests should be easy to create and maintain. Not only that, one of the greatest things about FluentAssertions is it clearly explains test failure results. You get better test results. And as a result of that, it means you need to do less debugging. So how many times do you, if I have a test failure and you immediately launch the debugger, set a breakpoint and try to figure out what's going on? I find that I'm actually doing that less and less with FluentAssertions because the better test results that it's providing means that I can see immediately what's gone wrong and how I can fix it. So I can jump straight into, fixing that red, moving on to green and refactoring. So overall, I found that FluentAssertions improved my productivity and simplified my approach. It's a great tool. You should check it out. You might be using Shoodly. I've used Shoodly in the past. I think it's good too, but I'm certainly enjoying switching it up with FluentAssertions. Okay, and next we have mock. I don't think it needs much of an introduction, but just in case, it's the mocking framework for .NET. I think it's a default choice for many developers. Now, according to the repo, it's very popular and friendly. Now, I can confirm that it's indeed popular, but I don't agree that it's friendly. It's never once greeted me in the morning. It's never given me any compliments. It's never said how nice and clean my code is, which I take a lot of time to try and make it nice and clean. But it is popular. It is probably the #1 choice for mocking frameworks. That aside, it does support mocking classes and interfaces, and it's strongly typed, so there's no magic strings. It's simple to use with no prior knowledge required. You can really do a lot with mock just by having a look at its fluent syntax. So next we have Respawn. So this is my favorite new tool. Respawn is an intelligent database cleaner for integration tests. And just in case you're wondering what Respawn is, what the word means, of course. It means that it's kind of like when you're playing a video game. Let's say you're playing Quake and you die, and then your character respawns and you can continue on to fight another day. So it's kind of like that for databases. It wipes the database to a clean state. You've got all your health back and you're ready to go again, ready to run that next test or ready to get that next frag. So what it does, instead of deleting data or rolling back transactions, it takes a performant approach by working out the relationships and deleting the data in the correct order. Respawn is easy to configure. You can set it to ignore tables and schemas, such as the EF migrations history table. And I'm going to show you that because if we're resetting the database to a clean state, that means wiping the data. Obviously, we can't wipe the EF migrations history table. Otherwise, it's going to be out of sync with EF core. So now it supports many databases such as SQL Server, Postgres, MySQL. Now I predominantly work with SQL Server, so I've only used it with SQL Server at this stage. The cool thing about Respawn is it's small and it's easy to learn. So I'm going to show you a lot in this talk, but if you'd like to learn more, of course, you can go and check out the repo. So now the best part of the talk, we can move on to the live demos. All of these demos are going to be run using the Clean Architecture Solution template. So this is something that I actually built for my talk for NDC Sydney last year, and it was based on everything that I'd learned in talking to people about clean architecture, presenting clean architecture and teaching clean architecture. So it's a .NET Core template package. You basically run .NET New CA Solution and you get a bunch of projects out of the box ready to go. It runs ASP.NET Core 3.1, Angular 9, Entity Framework Core 3.1, and ASP.NET Core Identity. So if you wanted to try it out, you just simply install it from the command line, .NET New install Clean Architecture Solution template, and then you can create a new project by going .NET New CA-solution, and it will create that project for you. Of course, you can learn a lot more at the repo, and I've got a link to that repo at the end of this presentation. But this is what we're going to be using for the demos tonight. The only difference is I've deleted the tests. Okay, so let's begin. Demo on clean testing. We're going to create tests that are easy to write and maintain with NUnit, FluentAssertions, mock, and Respawn. Okay. What I'd like to do is start with a little bit of a demonstration. So we're going to talk about what we're going to be testing. A quick overview of the project first. So when you run this .NET New CA solution, what you get out of the box is a single page application built on Angular with the ASP.NET Core backend, adhering to the principles of clean architecture. And so just briefly, it contains 4 projects: the domain and application layers making up core, the infrastructure layer, and the presentation layer, which is called Web UI. So that's exactly what you saw on the diagram. Now, I don't want to go into too much detail here because you can see that in the other presentation. We'll spend our time talking about clean testing. Now, the template also comes with, I think, 3 test projects. So really good examples of tests straight out of the box, including these subcutaneous tests that we're going to be writing tonight. So I have a little bit of functionality in here, and we're going to be testing that. This is my to-do list sample, and it's basically multiple lists and multiple to-do items with various capabilities for managing items and managing lists and creating lists and creating items. I had a little bit of fun working with it. So I created this much earlier in the year, and I thought I'll create a COVID-19 shopping list. And of course, it was easy to get apples, milk, and bread, but I wasn't able to yet check toilet paper, pasta, tissues, tuna, and water off the list. I think I had to meet the shady guy at the end of my street who had stocked up on these things. So let's write some tests. I think we need to look at writing a simple test first. And so we'll write a test for get to-dos. And that's what this view is driven by. It's driven by a view model called the to-dos view model. So let's give that a test. So in the application layer, I have this to-do list folder. And inside of there, I have a queries folder. And inside of there, I have a get to-dos folder. So let's have a look at this get to do's query. So hopefully this is nice and big for you, or I'll make it even bigger. So the way this query is structured is it has a DTO for the query request. And this might contain parameters to pass in as part of the request. So it might include some filtering options, some paging options, and sorting options, whatever it is that we wanted to include when we wanted to get a list of to-dos. In this case, I really just want everything, and I don't need to provide any arguments for this particular query. Now, just below that, in the same file, I have this get to-dos query handler. And this contains the logic for building the to-dos view model. And essentially what it does is it returns a to-dos view model, which consists of a number of priority levels and to-do lists. And each to-do list is made up of a to-do list DTO, and a to-do list DTO contains a number of items, to-do item DTO. So we're going to start writing some tests for this one. What did I change there? Oh, of course. Yep. Okay, so first we're going to create a new project. So I'm going to create it in this test folder, and I'll go add, new project. And of course, as I mentioned, we're using NUnit. So we're going to use an NUnit test project in .NET Core. Go next, and we will call it clean testing dot integration. We'll call it clean testing.application.integration test, because this is going to target our application layer. I could also call it subcutaneous tests. I might even change that at some point. So we're creating that. Just waiting. Now, I always like to run the default test just to make sure everything's working. We'll just make sure that we've got those dependencies restored. Take a second. This is all getting cleaned up. When I'm not recording and presenting live, it takes about 1 second. When we're recording and presenting live, I'm pretty sure that just took 10 minutes of my time. So anyway, we're there now. We'll run that. So I just went Control-RT, nice little shortcut to run this particular test. And we'll switch to Test Explorer. It's just doing a quick build. We'll just expand that out. There's absolutely no reason why this test wasn't run, but hopefully it'll warm up my Surface Book and make the rest of the presentation go a little bit faster. Maybe not. It's time to get a new laptop. Okay, that's all good. So we don't need that test, so we'll go ahead and delete that. And we're going to create our new test. So let me see. I will use my little snippets. And I have a cool little extension called add new file. You probably heard me talk about it before. It allows me just to specify the full path, including folders to be created and the file name. A folder structure and a file name that replicates the folder structure and file names that are in the application layer. So now my application layer is neatly organized, and so are my tests. So I've got this little nice test ready to go. Now I'm going to grab my stub for that test. And looks good. We'll need to bring in some namespaces. So we'll bring in NUnit. Good. We'll bring in a reference. Now I want to add a reference for this project to Web UI. So you might be thinking, why is he adding a reference to Web UI? Why not to application layer? That's what we're testing. Well, remember, we're going to set up the production scenario. And in Web UI is where we have startup.cs, and in startup.cs is where we configure our services. And we want to reuse that functionality. So I'm just going to go ahead and add a reference to Web UI. And of course, Web UI has a reference to application anyway. So now I'll hit Control dot. And we won't do that yet. Just wait for it to find its reference. Check. Better check. Make sure I didn't do anything wrong. Testing Web UI. Yeah, that's it. Okay, good. So now we've fixed up pretty much all of the references. Oh, we need to install some packages as well. So we're going to install FluentAssertions, mock, and respawn. Why don't we just do that from the command line because it'll be a little bit quicker. Drag that up here. That is slow. Okay, so .NET add, oh, there's an autocomplete, we'll use that. .NET add package FluentAssertions. And we want mock, MOQ. I should have just pasted this into the CS project. That'd be a little bit quicker. This is fun too. And respawn. Oops. There we go. Okay, we'll let that disappear. Respawn should appear here. And we'll be able to fix up those references. Yay. Okay, good. So back to the code that we're working on. So we just need to bring in FluentAssertions. Good. Almost. Didn't do it. Try it again. There we go. And we'll just clean up those namespaces. So that looks good. That's where I want to be. This is the test that I want to write. Of course, it's not going to run right now. I haven't wired up the database. I haven't wired up any production services. This little helper method doesn't exist. And so a little bit of an explanation on this helper method. So in the application layer, I'm using a tool called Mediator. And with Mediator, all of my commands and queries are defined as requests. And I can say mediator.send, and I can give it a query or a command, essentially a request, and it'll find the handler that's associated with that request. We saw an example of that just now. And then it will return the response. And so we want to send, we want our tests to run through Mediator. And there's a really important reason for that, because of course, we could just test the commands and queries directly, and we could actually just unit test them. We don't need to write subcutaneous tests for them. But when we're using Mediator, I have these behavior pipelines set up. So here's an example. Here's a validation behavior. Every request that comes through the system runs through Mediator, and Mediator will automatically validate any request. So it will just basically say, hey, if this request has any validators, then validate it. And if there are any failures, then throw a validation exception. So we want this to be part of our test. We want to test this whole pipeline. We want to test as much of the production scenario as possible. And so we definitely want to pass it through Mediator. Here's another one. Here's an unhandled exception behavior. It will automatically log any unhandled exceptions for any requests. So we've got a few other examples there. So let's go back down here. So really what we need to do now is to wire up our production services and to implement this helper method. But we also don't want to be dependent on global data for a couple of reasons. If we were writing our test this way, we're assuming that there is only one list and that there are only 6 items in that list. But this data is coming from somewhere, and typically when you see this, that means it's coming from some sort of global location. But of course, someone's going to need to change that data at some point to suit the needs of another test. And of course, that's going to break a whole bunch of tests. So it would be much better if we could set up the data that we need right here as part of this test. And then, of course, we have this new tool, Respawn, which is going to clean up the database each time. So we'll have a clean state for each test. So I've got a little snippet we can throw in. I'll grab that. There it is. And so here it is. So we're calling add async, and we're passing in a to-do list with a bunch of to-do items. So a nice little shopping list. So I'll bring in the namespace for that. You can see that add async hasn't been implemented yet because it's another helper method. it's basically going to allow me to pass an object graph, and it'll try to add it using entity framework calls DB context. And then we can set up our query, we can take an action, so we can send the query, get the result, and then assert on that result. So let's go to the next steps of getting that test to actually run. So what I'll do first is I'm going to create a testing.cs class. And this testing.cs class is going to be responsible for wiring up those services and also exposing some helper methods. So we've seen add async and we've seen send async, and we're going to add a few more along the way. So we're going to use some of NUnit's great mechanisms for managing global test setup. So we have this setup fixture, bring in that, and this one-time setup. So this is going to run for everything in this namespace, which is kind of the root namespace for this project. It's going to run this one time. And so we can use this to wire up our services, set up our database, and to set up respawn. So we'll leave that for the moment. Now I also want to create stubs for those helper methods. And so I'm going to put them just in here. Oh, I need to fix this up before that bites me. Look at that, I'm fixing my own errors tonight. This is going to be great. That one, and I'll come back to that because I want to paste this in. There we go. I'll come back to here, pop that one up the top. Hit Control X. I didn't think we needed to think about that. Okay, and Control D. Okay, that's looking better. Clean it up. Okay. So, yes, we need to bring a mediator. And I think that's it. So we've got our helper methods ready. What's it complaining about? It lacks a weight. That's okay. We'll come back to that. So we've got the stubs for our two helper methods, add async and send async. And we've got this one-time setup, which we can use to set up our services in our database. So if we want to now use these helper methods, of course, we could say testing.addAsync because they're static and we can access them that way. But we can actually use the using static directive, which is really cool. And if we say using static testing, then it's actually going to allow us to access those members without specifying testing all throughout here. So you can see those squigglies are gone immediately and knows where to find them. So we're going to see this appear in all of our test classes, and that's going to expose our helper methods. So why don't we come back here and start wiring this up. So the first thing that I want to do is wire up configuration. I'm going to need a couple of things. I'm going to need configuration, and that's going to be used to wire up our services. So I'm going to just steal from WebUI our app.settings. And I'll steal the whole lot because we'll need something from dev as well. We'll just drag that in there. Okay, so I won't need anything from production, so we'll delete that. From development, I want this configuration for identity server. It basically says that it's running in development and we don't need to wire up an SSL or anything like that. So I've got that in clipboard, and so then we'll go to app settings. And I can put that in here. And now I just want to change my name is already changed. That should actually not be like that. Let's change that because I'm going to commit all of this code for you at the end so that you can see the demo. So that one should be our clean testing database. And this one is our very much separate clean testing test database. It's starting to get confusing. But anyway, that's all we need for configuration. One of the features that you'll notice in the Clean Architecture Solution template is out of the box, it'll use an in-memory database by default. And so I just need to make sure that that's set to false. Otherwise, it won't bother looking at the connection string. And that's just so that people who are on Windows, Mac, or Linux, they can get up and running without having to set up any kind of infrastructure. So it just makes it easier to use the template because maybe, the template comes with SQL Server. But you might not like SQL Server. Maybe you're going to switch it to Postgres or to SQLite or whatever your favorite flavor is. So we've got our app settings, And so we want to now grab that configuration. So I've got a snippet for that. Okay, so we can see that we're using the configuration builder to read that app settings file, in the namespaces, and then we're creating a private static variable to hold that. I guess I'll type that out by hand. Should be okay. Okay, that's not used at the moment. And so that returns our configuration. So next we're going to wire up our services. So that's pretty easy to do. So if we go var services equals new service collection, I'm going to fix up that error. I feel like someone's helping me tonight. There we go. Okay, and that one. And now, so now what we want to do is we want to grab startup, because remember I said in web UI we have startup, and startup has our method configure services. And so configure services wire ups all of those services for us. And we want to reuse that. We don't want to have to write it by hand. When I first started out trying to figure out this approach, that's exactly what I was doing. But fortunately, I found a lot of great resources, and I'll share those with you at the end. So say startup equals new startup and pass in the configuration. It needs configuration. I think that's good. Maybe a reference. There we go. And now we could just call startup.configure services. And we pass in our services and it'll configure them for us. It's so good, right? So simple. It's all done. No, not really. If only it could be that easy. There is a gotcha. If we were to run that now, we'd encounter an object reference error, and that's because we're trying to register identity services, and it actually needs a iWebhost environment. And so we're going to create a mock of iWebhost environment so that we can avoid this error altogether. And so we'll use mock for that. So we need to do that before we call configure services. So we might just do it here. So let's see, services dot add singleton, and this is going to be a mock, and we'll bring in moq dot of iWebhost environment. And basically what I'm doing is I'm just creating kind of a bare bones mock that will suit just the needs that identity has, so that we can avoid this issue altogether. And it took me a little while to figure this out. I had to actually troll through the ASP.NET Core source code to figure this out. But I've been doing that more and more lately, so it's been pretty useful environment. That's the great thing about it being open source, right? We can jump in and we can just see how it works. So the environment's going to be development. Probably could grab that elsewhere, but anyway. I'll bring in that namespace because that's quickly starting to annoy me. And then we'll say w.application name, and that's just going to be simply clean testing.webui. I think that's what we need. Okay, good. So now when we configure our services and it tries to wire up identity, it's going to be able to find iWebhost environment and wire that up for us. So now when our requests run through ASP.NET Core Web API, they're kind of running in a small scope. They're running in a request scope. And so we kind of want to replicate that here. So we're going to create a scope factory that we'll share as a services.build service provider.get service, iService scope factory. Looking good. Hopefully I can get some help there. Yes. And we'll just make that static. I'd like to use ReSharper, but I don't think my Surface Book can take anymore. It's time for a new laptop. All right. So we've got that in place. And so now let's flesh out our helper methods. So we'll start with a snippet for this one, save a little bit of time. Okay, so you can see here we're using our scope factory to create a scope, and then using that we're able to actually just grab the DB context. So we say scope.serviceProvider, which is our service provider, .getService application DB context. And we're able to do that because we wired all of our services by calling configure services. And if we look at configure services, it had some extension methods to wire up infrastructure. And inside of infrastructure, this is where we wired up our database. Okay, so all of this is happening now for us in our tests as part of that one-time setup that we're using. And yeah, this was a big reason that I went with NUnit. I just really like how easy it was to create integration tests and how our needs for managing global shared state were met by this one-time setup. You can do it in the other frameworks, but it's not quite so easy. Let's see. So we've got that one in place. Now we want to do our send async. And this is similar, but we want to get mediator this time. Because it's going to be responsible for sending our requests, our commands or our queries. So we'll say mediator equals scope.serviceProvider.getService mediator, just like that. And then we can just say await mediator.send and our request, which we passed in here. We want to return the result though. And that's defined by kind of the type of request that we made. So we have a I request of type T response. And so if we're looking at our back at our get to do's query, you can see that it is an I request of type to do's view model. So we could pass in a get to do's query, which would return a to do's view model. And that's exactly what we're going to do. So everything in place. I think we can run that test. There's a little bit of setup, but after that's done, we're good to go. Get to do's tests. We'll call it get to do's queries tests. Anyway, doesn't matter. Let's run it. Control RT. So this one will take about 2 seconds to run, maybe a bit longer. So I assume that's going to feel like 20 minutes. So we'll just have to be patient. Let's see. Unless it fails, and we'll have to debug it. Be very patient. Let me see if there's any questions. Doesn't look like it. That's okay. We'll have time for questions at the end, hopefully. And also we'll have time for questions in the Slack channel afterwards. I'll be sticking around. There we go. That took a long time. Okay, that took 15.9 seconds. So obviously the load on my system is more than I expected with the live streaming, but that's okay. We'll still be able to do this quite easily. So this failed, but it failed for an okay reason. We were gonna get there eventually. Just remember to keep on mute if you don't mind. So the reason that it failed is it expected result.list to contain 1 items, but it found 2. And this is coming from FluentAssertions. You know, we're seeing those really good test results and those error message, and we're seeing result.lists, which was part of the actual variable name. So it's really easy to understand what happened. So essentially what's happening is that there was some data already in the database. And when we ran this test, it failed. And it was because there was just two items in the database. And that's simply because we're not cleaning up the database yet. So now we need to start using respawn so that we can clean up the database. And the way we're going to do that is we're going to reset the database back to a clean state before each test runs. We could do it after each test runs, but that can be kind of problematic because what if the test fails to complete and it doesn't do its cleanup? So it's better just to do it before each test runs. So let's do that now. So back to testing.cs. And And here we go. So we're going to create a new checkpoint, and obviously that's going to be a field, call it new checkpoint, and that comes from respawn. So we're bringing the namespace for that. And we can create it just like that. And if we don't have any, configuration to provide, then that's fine. But as I mentioned earlier, we're going to need to exclude or ignore the migrations history table because we don't want it to wipe that. So this is expecting an array, and the table name is EF migrations history, just like that. Good. And that's pretty much it. I'll do one other thing, which is just a little bit nicer. We'll make sure that the database exists and that it's up to date with the latest migration so that we don't have to deal with that in the future and you don't have to go and create it before you run the test because that could get pretty annoying. So we'll just call that method ensure database. And we'll just pop that down here. So ensure database. I should put in a few more things there. Okay, we'll still that, and we'll still that as well. Okay, and all you have to do is say context.database database.migrate. I saw a question come up there. It's an interesting question, and it was one of the reasons that I went with NUnit. So these tests are not running in parallel; they're going to run synchronously. Because yes, otherwise we'd have trouble maintaining the database, and side effects would be aplenty. So yeah, we're running them synchronously. Okay, so database.migrate, and I think that's everything. Now we need a method which is going to use this checkpoint field to reset the state. So we'll create a public static async task reset state, and we'll say await checkpoint dot. So why not use transactions? So we found this approach just to be a little bit cleaner, a little bit easier to manage. You could definitely use transactions. But I wanted to give this approach a try, and it's been working nicely for me. So the other question I saw pop up, which was cool, I like how that's working, is NUnit only synchronous? No, NUnit can also run tests asynchronously in parallel, but its default option is to run tests synchronously. And that's in contrast to XUnit, where its default option is to run tests asynchronously. And of course, XUnit also supports running tests synchronously, although I had a lot of trouble getting that to work with XUnit because it's a supported feature, but I think there's some difficulties with XUnit and maybe Visual Studio 2019. There's some issues on GitHub and in forums, and yeah, it doesn't seem to be solved yet. So hopefully they'll solve it soon. Anyway, I'll get this set up and we'll continue on a little bit, but I'll try to come back to some of these questions as we go. So we do have a lot to cover. Configuration.get connection string, default connection. Okay, so that's going to reset our database, and it's going to reset it based on the default connection, which is the same connection string we're using to wire up our DB context. So now we need a test base, and we're going to use the test base to contain our setup logic for our tests. So these are we're going to run this logic before we run our tests. And so to do that, we'll call setup from NUnit. There it is. And public async task setup. And we'll go await reset state, which doesn't exist, but of course we can do that because we're going to use the using static director. So using static testing, and that will work. Clean up the namespaces. So that's looking good. So now to use that, all we have to do is actually get to-dos tests to inherit from that. And so that will run the setup, then it will run the test. And if we had specified any kind of cleanup in the test base, it would have run that too. Now, I'm not going to run that test because it's gonna be a little bit slow. What I'll do is I'll complete all of the tests and we'll run them at the end. So hopefully we can see them complete successfully. But I don't want it to run for 15.9 seconds again because that was felt like 60 seconds. So okay. So what I want to do now is try creating some tests for a command. And I can see we've got about 10 minutes left, so I'll speed it up a little bit. So I'm going to use my snippet so we can create it with the folders and the files like this. Okay, so we're going to create it in to-do list commands, create to-do list tests. And I will grab the stubs. Good. And bring in the namespaces. And we'll bring in our using static testing. Good. And so for the first test, require minimum fields, we're going to check that our validation is working correctly. And remember, that's coming from a pipeline behavior. And so that behavior is going to run before the request runs. It'll validate any request that comes through the system. So I'll grab that. And we'll bring in reference to FluentAssertions and the create to-do list command and the validation exception. Now that we have to be careful to get the validation exception from the clean testing application common exceptions, because that's a custom application exception I wrote rather than the one that's in system.componentmodel.data annotations. Okay, so what's happening here is we're creating a new instance of the command, but we're not filling out one of the required fields, which is title, and that's marked required because we're using Fluent validation, and it's specified that it must not be empty. And back a little bit. Then we're using Fluent actions. We're going to say, in invoking send async, the command, it should throw a validation exception. So this is a good example, but we really need to flesh this test out a little bit more. It says we should require minimum fields. We probably need to get a little bit more specific about exactly what validation exception was thrown and what errors were contained in that validation exception, which is contained in this dictionary. So there's an errors dictionary as part of this class that you can interrogate. And we're not going to do it for this test, but we will do it for one that's coming up. Okay, so that test is complete. Again, we won't run it. We'll wait till the end to have that fun. So now I want to write a test for requiring a unique title. And this is another part of the validation that's happening for this request. We'll basically check to see if that title already exists or not. And if the title does exist, then it will throw a validation exception. So we do that by setting up our data in the database. First, we create a new to-do list with the title shopping, and that happens immediately using send async. Then we create the to-do list command, which we will use to then, as part of FluentActions.invoking, send that request and assert that it should throw a validation exception. So again, we should dig a little bit deeper there, and we will in an upcoming example. Okay, and finally, for the create to-do list command, this last test should create to-do list. We're going to do a little bit more. Remember that we're using ASP.NET Core Identity in this system. Well, these to-do lists are created with a user ID, the currently logged in user, and they're modified with a user ID as well. So that if we were to run an update to-do list command. And so I want to test that as well. So you can see we're going to introduce a couple of new helper methods. We're going to run as a default user async, and that's basically going to create a user in the database and give us a user ID. And it's going to do that using ASP.NET Core Identity. Then we're going to actually create this new list, which is going to be called tasks. We'll get the ID, and then we'll find that list in the database. So we'll introduce a new method called findAsync, will allow us to grab an entity from the database, and then we'll run our assertions against that list. So the first thing we need to do is implement these two methods. So we'll start by implementing find async, and of course we're going to do that in our testing helper class. We'll do it just after, actually, we'll do it just before add async. Okay, so you can see it's similar. We grab the DB context, and then we call find async based on the entity that was specified because it's generic, and passing in the ID. And so that'll return it if it exists, otherwise it'll return null. So the other one that we wanted to implement was, we need to bring in that namespace. And we need to run as default user async. So let's see how we can do that. So this method's going to allow us to work with a valid user ID. And so I'll bring in some snippets and we'll have a look at those. We will add these after the database stuff, maybe just here. Okay, so you can see there's two methods. We're using run as default user async, and all that does is just specify some dummy data for a user to create. So there's a username and a password. And so then in run as user async, it takes that username and a password, grabs the scope, and it grabs the user manager from ASP.NET Core Identity. And the application user is how our users are defined. It's the identity user. So now you can see we're creating a new instance of the application user using the username as both the username and the email. We're making that request to user manager. So we're creating that user, specifying the application user and the password. And that, if successful, will return us a new user ID. And so we're going to store that as a static field so that we can access it as needed. Now, remember that we're also resetting the state of the database before each test. And so that means that this user is going to be cleaned up before each test. So we also need to, when we reset the state of the database, just set that to null. So we'll do that here. There we go. I think that is everything. Oh yes, there's one more thing we do need to do. So we're using an iCurrent user service to get the current user, and that exists in the application layer, and it's used by any request that would like to get the user ID of the current user. The current implementation for that is in Web UI, and it requires a valid HTTP context. But we're not doing ASP.NET Core integration testing, so we're going to create a mock for the iCurrent user service instead, and that mock is just going to return the current user ID if it's set to a value, and you know, whether it's set to a value or not really. So the way we have to do that is we have to actually remove the existing registration of iCurrent user service and then add a new registration for testing, and we'll use mock to create that registration, just as we did with the iWeb host environment. So I'm going to pop that in right here. No, I'm not. That would be a bad place to put it. We need to do it after configure services because that's where the Web UI version is going to be registered. So we replace the service registration for the iCurrent user service, bring in link. And we do that by first finding the current user service descriptor. We can then remove it from the services collection, and then we can register a new one as iCurrent user service, and it sets it up so that user ID will be equal to static current user ID. Okay, so that's it. With that in place, those tests would all run. And I should say, you know, the tests are running slow tonight, but that's just because of the live stream. Now, I've got about 18 tests on the clean architecture template. There's more added all the time, and they run in about 1.8 seconds, so about 100 milliseconds per test, which is pretty amazing considering we're wiring up all of these services. We're programming against a live database, so it's pretty great. So that is done. So I wanted to create one more set of tests, just the update to-do list tests. And then I think we'll run those tests and provide a summary. So the update to-do list tests, we can put in this here, update to-do list test.cs, and I've got a snippet so that we don't have to jumps through hoops. Now this has some similar logic to what we've covered in the create to-do list, but of course it goes into a little bit of detail and showing, hey, we need to set these things up ahead of time because we're not going to be dealing with this global state. So I'll paste that in and we'll bring in the namespaces. Here's a handy hint if you're not using ReSharper. If I hit Control A, Control X to cut it, Control V to paste it, jumping through hoops, right? Then I can press Alt Enter and add missing usings. It's hard to see, it's down the bottom here. It'll go ahead and add all those usings in for me, which is kind of nice. There we go. We'll clean that up so that'll be ready to run. So that's simple. So, you know, we're seeing these tests now. They're easy to create. They're going to be easy to maintain, and they're also easy to understand. So they're going to provide system documentation for the users who come along, and they're testing a whole lot. And in testing that much, it's going to give us great confidence that we can deploy these changes to production. So what I'm going to do is I'll run all of these tests and we'll do a little bit of a wrap up and we'll come back and just see if they pass. So hopefully you get to see that. Now I'm also going to check in these changes so you'll be able to access the sample repo as soon as this presentation is finished. So wrapping up, resources. So first and foremost, there's the clean testing demo code. So this is where I'm going to post the demonstration code. The repo is already there. It's in its initial state where we started tonight, and I'll do a commit that's at the end of this presentation. There's also the clean architecture solution template. And so if you wanted even more tests, then you can just go .NET new CA solution from the command line, and that'll bring those up for you. Now, the next two resources, Contoso University by Jimmy Bogart and Fixie Demo by Patrick Loy, were a major source of inspiration for this approach. Now, you have three really cool resources. You've got the Clean Architecture Solution template, which is using NUnit. You've got the Contoso University sample, which is using XUnit. And you've got the Fixie demo, which of course is using Fixie. And they all have something a little bit different in them. So there's good things to learn. So I recommend you check them all out. But the other point to make is that, you know, it doesn't matter which framework you're using, what your preferred framework is. Now you have a good example of any of these approaches. So hopefully you'll be able to get started. So let's do a quick summary. So tonight I've shown you clean tests that are simple to create, maintain, and understand. These tests were configured to run against production services, against a real database, and helped with verification. Testing tools such as mock and FluentAssertions improved our simplicity and productivity, and we used respawn to reset the database state back to a clean state before each test was run, and it gave us a known starting point for each test. Now, this approach results in better test coverage and higher confidence. So before we finish up there, let's just see if those tests all succeeded. That's good. I'm very glad about that. So yeah, we've got 7 passing tests. It took about 8.5 seconds, which is super slow, but that's okay. When you run it for yourself, you're going to see that these tests run really quick. So we're no longer constrained by that pyramid. We can write with modern technologies, modern tools, modern approach. We can write these tests that run fast and give us super high confidence. So the confidence to deploy your system to production, knowing that it will behave as expected. That's it for me. Stay safe and keep testing. Thank you. So I'll be heading over to the Slack room now, and we can continue that conversation.